Okay, this is a walkthrough of calculating components of a vector in various coordinate systems. I am going to do this with a vector that's going to be really important to us. You'll see this later when we get to rolling and sliding problems in Newton's laws. Okay, so let's say that the vector we have is this, just pointed straight down, and it has a magnitude of 9.81. Okay. And let's say we want to calculate this in 3 coordinate systems. So the first one, we're just going to use our most familiar coordinate system. The second one, we're going to use a coordinate system that's rotated where this angle is 20 degrees. And third, we're going to use a coordinate system where this angle is, let's make this 30 degrees. Okay, so how do you do this? So one by one, remember that you don't change the orientation of the vector. You just put the vector at the tail of the vector at the origin of the coordinate system, and then calculate the counterclockwise angle from whatever the x-axis is in your coordinate system to the vector. Okay, so let's do the first one. So here's our coordinate system. Pause the video and put the vector tail at the origin of the coordinate system. Okay, so there's the vector. It has a magnitude of 9.81. And now pause the video and calculate the counterclockwise angle from the x-axis to the vector. Okay, so the angle we want is all the way from this x-axis to the vector. So that's 90 degrees, 180, 270. So this would be 9.81 times the cosine of 270, 9.81 times the sine of 270, and that just gives you 0, negative 9.81. Okay, well, that makes sense because if you look at this, that vector is just going in the direction of the negative y-axis, and so we should only have a negative y component. So that all checks out. Now let's go to the second one. So our coordinate system is this. Pause the video and place the vector here. Okay, so remember this vector just goes straight down. The magnitude is 9.81. And now pause the video and see if you can figure out the counterclockwise angle from the x-axis to this vector. Okay, well, the angle that we want goes from this x-axis to this vector. since the x-axis of this coordinate system is tilted 20 degrees from the horizontal, that means that the negative y-axis, which is, notice that this negative y-axis is at 270 degrees, but that's also tipped 20 degrees past the vector. So this angle is going to be, if we went all the way to the 270, it would be 270, but we're falling 20 degrees short of that. So the angle here is 250. And so our vector components are going to be 9.81 times the cosine of 250 degrees for the x component, and 9.81 times the sine of 250 degrees for the y component. And if I calculate that, I get negative 3.36 for the x component and negative 9.22 for the y component. Okay, is there any way to figure out if this makes sense? Yeah, because remember that there's a correspondence between the coordinate of the head, the coordinates of the head of the vector, and the vector components. So think of what you would have for the coordinates of this point right here. You would have a relatively small negative x component and a relatively large negative y component. You're in the third quadrant, so you know they're both negative, and that's what we get. Okay, so now the third one, part C. Here's our coordinate system. Pause the video and place the vector where it should go. Okay, so there it is, 9.81. And now see if you can figure out what this angle theta should be for this coordinate system. So pause the video and see if you can figure that out. Well, the angle we want goes from the positive x-axis around to this vector. This would be the 270 degree line, so we can see we're going past that. And the amount we're going past it is 30 degrees. So theta here is equal to 300 degrees, 270 plus 30. You also could get there going clockwise, 60 degrees. So you could also write this as negative 60 degrees and you'd get the exact same answers. So now pause the video and see if you can come up with the components using this angle. Okay, the components then should be 9.81 times the cosine of 300, or you could use the negative 60, you'd get the same answer. 9.81 times the sine of 300. And the answer you get is 4.905 for x and negative 8.50 for y. Does that make sense? Yes, the head of this vector is in the fourth quadrant, so we should have a positive x and a negative y. And you can see from the drawing that the positive x should be relatively small and the negative y should be relatively big.